This is the second part in IDI's series on SMC familiarization. I'm Rob Holcomb, Engineer and Product Manager here at IDI. In this part, we cover compounding, the process of producing sheet molding compound. After the design lifecycle completes validation and serial production has begun, IDI will produce that formulation at our production facility on one of our production SMC lines. Orders for parts flow from the OEM to our customer, the molder, who in turn sends us orders for molding compound. IDI gathers and mixes the raw ingredients, compounding them into SMC. The SMC is then matured for a period before being shipped according to the customer's release schedule. Shelf life, release regularity, molding production rate are all important design factors IDI uses to plan and design an SMC to order. Compounding refers to the combining and consolidating of raw ingredients into the SMC format. Wet and dry ingredients are mixed to produce a paste. Fiber rovings are chopped to a designed length, usually 25 millimeters. The paste is poured over the chopped fiberglass at a certain ratio. The mixture is sealed between layers of carrier release film, then compacted through a series of rollers. The compaction section wets out the fibers with the paste, ensuring a consistent ratio of resin to glass throughout the length and width of the sheet. At the end of the line, the sheet is festooned, layered back and forth, into a large box or returnable tote, which becomes its storage and shipping container. Thermoset compounds like SMC rely on chemical reactions to achieve their cured state. This permanent reaction gives thermosets their unique strength-to-weight ratio. The reaction can be thought of as happening in two stages. An initial stage we call thickening, where the ingredients are first mixed and their viscosity climbs from fluid to viscous to tacky and near solid. We control this stage by maturing the SMC in an elevated temperature for a certain amount of time. After maturing, the SMC is moved back to room temperature or refrigerated storage and kept there, whether at IDI or our customer, until it's ready to mold. The second stage of the reaction occurs when the extreme heat and pressure of the mold kicks off the curing reaction, and the part solidifies. Maturation is an important process for maintaining the moldability of SMC. There is an optimal window of viscosity that allows the SMC to flow and fill a mold properly. That window varies with each formula and each tool, hence the importance IDI places on collaborating on release size and production volume early in a project. After compounding and maturing the material, a key challenge is flattening the thickening curve of the paste, which is to say keeping it from aging or curing further. This is typically achieved by the design of the chemical compound and by the design of the storage and shipping conditions. With the SMC matured to release viscosity and a customer release order, IDI loads the SMC on the customer's truck for delivery. Care must be taken not to expose the SMC to high temperatures during shipping, as this may kick off the curing reaction and make the product unusable. It is recommended that during warmer months, customers use temperature tracking probes, refrigerated trucks, and short hauls to mitigate the risk of this happening. Just as shipping SMC in a controlled manner ensures arrival to the plant in good condition, receiving and storing it under tight control ensures it arrives at the mold just as well. SMC is continuously thickening over time. Lower temperatures mitigate and higher temperatures exacerbate this process. This is a key driver of what many call shelf life. Each customer, each application, will have a unique idea of what's moldable and what isn't, and that has an immense impact on each unique definition of shelf life. Taking care to immediately unload and store SMC in a controlled environment will help keep the material molding the same run after run. A controlled environment is one with fairly constant temperature below 25 C, preferably in the range of 4 to 22 Celsius or 40 to 72 Fahrenheit. Location considerations include exterior walls or doors that can cause seasonal temperature swings, and windows and heaters that may pass ultraviolet or infrared energy to the SMC. IDI works with our molding customers to balance the size of SMC runs and releases against a formula's maturation rate, as well as the customer's production rate and storage capacity for compound, work in process, and finished goods. This concludes Part 2 of the SMC series, Compounding. Part 3 is a dive into compression molding, where SMC is molded into its final part shape.